Welcome to KTH CNC's second official tutorial. The first tutorial, which had the intention of being a much more condensed version of a previously created tutorial in an unofficial matter, it turned out to be even lengthier than the original one. So this second official tutorial will be the same as the first official one, but much shorter. This will be the unannotated one. I will only show you what I'm doing. If you want to know deeper and more detail about how and why I am doing it, then the other tutorial has already been recorded. But this will be the short version, I promise. Folder here where I have my height map. No, sorry, where I have the height maps from SLU. I'll drag this in here. Very good. I'll make sure to go to Raster and miscellaneous and merge, and the input layers should be all of these, and should be float 32 should be saved to a file, and this should be perhaps here then 23 02 24. All right, QGIS. And this is Hagaparken and merged. Very good. Very good. Has an output. We will simply merge this. Run. Very good. Close. Delete these. Very good. All right, then we'll crop. So I'll drag in an OpenStreetMap layer here just to be able to see what I'm doing. And then go to vector, no, to layers. I create a layer, a shapefile layer, and the file name here. We are in the previous one. Let's make sure that this is 2302. Crop. Very good. The geometry type is polygon, and it should be in the project coordinate reference system. Very good. Okay. Let's edit this layer and create a new polygon here. We can do like that and that and that and okay, containing all that I want to be contained, and okay. Very. Toggle editing and save. Drag this. No, this. All right, let's disable that visibility here. We can toggle that. All right, right mouse button, click here, export, save as, raw data, and I'm going here, saving this with the crop. No, sorry. Yes, there and there. This is the cropped one. All right, it's in the coordinate reference system of our choice, and the crop should be from the crop layer, and we sealing this. Let's make sure that this hits the ceiling of 2, and this hits the ceiling of 8, and this is lowered to the floor of 8, and this is lowered to the floor of 4. Very good. All right, 1 pixel resolution per meter, and let's make sure that we have this as a file. Very good, and okay. Right, we have our crop. We can disable that crop there. Very good. Now this should be, let's first make sure that we have actual precision here, or actual accuracy for the values here, so that will be reflected in the information tab as well. Apply, information, go down here, and let's save our relevant values here. So the extents, go to the text editor, is that there, good, and the width and height. And let's see here, the maximum and minimum, and we can bring the mean, no, we can take those two separately. The maximum and the minimum. Very good. All right, that's enough. Okay, let's make sure to have the toolbox active here and go to raster analysis and raster calculator. Let's make sure to reference the layer of our interest, the cropped one, very good. And here, let's take the expression from the earlier tutorial, very good, this one here. Paste that expression there. And now we want to replace that input layer there with cropped, very good. X should be minimum, so let's go to our notes here, and we have a minimum here. Minimum and minimum, including the minus sign for this minimum value. And the maximum here. Very good. This remaps it to the full range, but I should be short on explanations in this tutorial so as to make sure that it's efficient in time. Very good. Let's make sure to save this as an actual file. Yes, we are correct here. This is the cropped, and this is 32-bit file format, but this is remapped. No, yes, it is. It is remapped to 16 bits. All right, and then let's run it. Very good. Now we have it here. Looks the same. Very good. And we can double click here and go to symbology and max value and actual and apply. Looks very good. Okay. All right, now this is remapped, but we need to convert the file format as well. So let's go to GDAL and raster conversion and translate. And then we'll make sure that that is selected. Very good. And we'll go to advanced parameters. And we'll go down to output data type and unsigned integer 16-bit. And the file should be a file saved, and that could be, it could be named simply the file name we have here, the 16 bits, because that is the aim of these operations. Save. All right, let's run this. And no value or no data value has been clamped to 0, as should be. Close. All right, let's see here, and we can change the accuracy for this one to actual and okay, and it is good enough. It is erroneous to, it has a very annoying 0 there, but now it is gone. Okay, or a 1 value was it? Very good. Okay, it has an inherent error of a third or a fourth of a millimeter, and that is okay. Very good, that is already saved. We have it here. If we go up to the 16-bit tutorial second try, and we have it here. Very good, this can be used in Rhino. So let's make sure to open Rhino, and then we can make sure that we are in meters. Very good, okay. Work in top view, and then we should type Heightfield here, and we are in the old tutorial, make sure that we are in the new tutorial, and here we have the 16-bit, very good, open, and first corner, if this would necessarily be in the SWIREF coordinate system, we would use these coordinates, which are the X and Y minimum extents, as the first corner or the lower left corner, and then for the length in the succeeding, we would use the width of the input height map. But since we want to CNC fabricate this and as is, and it's not necessary to have any more information in the correct projection reference CRS coordinate reference system, CRS. All right, we can just take origin, so the origin 0, and then the length should still be the width here. So I'll just paste that there. And then the number of sample points, this can be the width and the height, or perhaps a factor of this, or like half of it, or a fourth of it, depending on your computer's processing power and the like. The height is calculated from the maximum minus the minimum. Since the minimum is negative, it is in effect 72.87 plus 0.11. Very good, that is 72.98, and we want to create an interpolate surface for samples. Okay, and we don't want to save this before, since the only thing we have done in this blank document is importing this height field after changing the units to meter. No. We allow it to process here. All right, we have it here. We go to the, we can actually change the view here from top to perspective. And since this is positioned with 0 as its lowermost left corner, we can also shift it up 0.11 meters. So we can do that. Shift it down, sorry, because it was a negative value. I highlighted only the value, but it has a sign here, a minus sign, so it should be shifted down. Shifted down 0.11. All right, very good. And now we can go to top view and show rendered perhaps. And it's fairly difficult to see. We can go to shaded, and these sort of artifacts, they actually help us in determining where we are. So I'll make a polyline. I'll do it fairly simple this time. Like that, see to close. We can do this and split it with the curve that we have here. And then having split those and waited for the mesh, for the implicit render meshes to be generated as well. We can control click the interior and delete the exterior. Very good. We can delete that curve as well. All right, and this has serious mesh generation errors. When looking at in shaded view mode or in wireframe view mode, we see the control curves and they look very good, but the mesh generated implicitly is not very good. If you go to rendered, so we will generate our own. Go to shaded and click this and mesh. And then density 1, maximum angle 4 degrees, maximum aspect ratio 6, and minimum edge length 10th of 1,000 meter. Make sure to refine mesh and OK. All right, cell last to select the previously or the recently generated mesh. Let's move it here. And now we are in shaded view mode. Let's go to rendered view mode and zoom to selected to orbit around it. This looks good enough. Very good. So this is only to confirm that we have generated a BREP surface, as we can see here with the control curves, or perhaps more clearly with the wireframe where there is no implicit render mesh. And from that we have created our mesh. Very good. We can do this, duplicate border, extrude, curve, and extrude it down to there. We can delete that curve. We can make a plane, and that plane can be from there to there. I was a little short there, but it's okay. We'll just move it. All right, and we'll position it where we want it to be. We can take that and split it with that. And we can control click that and delete that. We can split this with the remains. Then we can keep that, so delete this. All right, then all of this is joined. Creating meshes for that. And then we can go to render this a letdown. But we still know that the geometry is sufficient enough to generate a mesh as adequate as this. Let's conclude here. And if you want a more detailed and more explanatory tutorial, then the first one is the one to watch. Thank you for your time.